Today is an exciting day. I have bought all these components to build my next video editing PC. I call it Beast PC number 3, and that is to replace my Beast PC number 2. I've been using Beast PC number 2 to edit the videos that I put on my YouTube channel. Beast PC 2 is an old PC. It is 10 years old, has an Intel i7-950 CPU. It has 18 gigabytes of DDR3 RAM, and it has a 1 terabyte Western Digital RE3 hard disk drive. It's been a great PC, but over the last year, I found that it has been too slow, so I decided to buy these components and build my next Beast PC 3. Beast PC 3 will have a MSI MPG Guardian 300p computer case. It will use this Antec NE1000G-M ATX 3.0 power supply. It will have this Intel i9-14900K CPU, and the CPU will be cooled by this Thermaltake Tough Liquid 360 liquid radiator cooler. The motherboard will be this Gigabyte Z790 Aorus Pro X revision 1.0. It will be equipped with G.Skill Trident Z5 64GB DDR5 RAM. And for storage, I will have two Western Digital SN850X 2TB SSD drives set up in a 1+1 RAID 1 configuration. I'll be reusing this Gigabyte GV-N16560C-4GD graphics card. And finally, I'll be installing Windows 11 Pro operating system. So join me in this video as I unbox each of these products and install them to build up my Beast PC 3. This is exciting for me. Let's unbox this Gigabyte Z790 Aorus Pro X gaming motherboard and see what is inside. There's the motherboard. Let's remove this packing. There's nothing inside. Next, the motherboard is in a plastic package. Put it to one side. Let's see what else is in the box. Lift the bottom off, and there's nothing else. It's purely a packing. Inside the box, there is a very simple instruction sheet on installing the CPU and installing the memory expansion card. Instruction sheet which covers a range of the Z790 Aorus products. It does say what versions of motherboard have been released. For the Aorus Pro X, it says there's revision 1.0, which uses the MediaTek MT7927 RZ738 wireless module. And for the Aorus Pro X revision 1.1, it uses the Intel BE200 wireless module. There is a Gigabyte warranty card. There is a warning label that the product contains a button battery, which is for the CMOS. There is a package containing the noise detection microphone. There is a package containing two sets of SATA cables. One of the cables is right angle and the other cable is straight. There is a package containing Gigabyte's G connector, which allows connection to the power, LED, CL, RES, and HD. There's a package containing the antenna for the Wi-Fi system. There are two packages containing the thermal sensors. I'll put these back in the box. Let's have a walkthrough of what's on the motherboard. So that's the LGA 1700 socket, and I'll be installing a Intel i9-14900K CPU in there. These are 4 DDR5 RAM slots. The specifications say that they are capable of overclocking to 8266 MTs per second. Each slot is capable of supporting a maximum of 48 gigabytes. That gives a total of 192 gigabytes across the 4 slots. I will be installing this G.Skill Trident Z5 DDR5 64GB RAM which is comprised of 2 RAM cards. This RAM slot is called DDR5-A1, DDR5-A2, DDR5-B1, DDR5-B2. So there are 2 channels. For a 2-module RAM installation, I'll be installing one RAM module in DDR5-A2 and the second RAM module in DDR5-B2. The motherboard has 5 M.2 storage interface connectors. The first M.2 connector is underneath this heatsink, and the next 4 storage interfaces are underneath this heatsink. To remove the first heatsink, just flick this lock clockwise and the heatsink springs up. Slide it out. This is the heatsink for the M2C-CPU. On the underside of the heatsink, there is a protective film that must be removed when installing the M.2 SSD device. There is also a protective film on the base of this M.2 connector that must be removed when installing a M.2 SSD storage device. This M2C-CPU connector caters to either a Type 25110 PCIe 5 SSD or the shorter Type 2580 PCIe 5.0 SSD device. Let's now remove this heatsink to see the other M.2 connectors beneath. Flick this lock switch clockwise, lift it to remove. So the heatsink, when I turn to the underside, also has protective film which needs to be removed when installing an M.2 storage device. This is the M2A-CPU connector. It supports Type 22110 and also Type 2280 PCIe 4.0 SSD. There is a locking switch here, but I do not understand why there is no locking switch here, even though it caters to the Type 22110 SSD. These 2 M.2 connectors connect directly to the CPU. These 3 M.2 connectors connect to the South Bridge. This is the M2Q-SB connector. It supports Type 22110 and Type 2280 PCIe 4.0 SSD device. This is the M2P-SB connector. It supports Type 2280 PCIe 4.0 SSD device. The 5th and last one is the M2M-SB connector. It supports Type 2280 SATA and also PCIe 4.0 SSD device. I have 2 Western Digital SN850X NVMe SSD drives. They are 2TB drives and they are of the Type 2280 PCIe 4.0. This is the MediaTek chip for the Wi-Fi as well as the Bluetooth. These 8 slots here are the ATX-12V-2x4 Set 1, Set 2. This is the CPU-op connector. This is the CPU-fan connector. This is the ARGB-V2 Set 2 connector. This is the ATX power socket. This is the System-fan 6-pump power connector. This is the USB-DP socket. This is the F-U32 connector. This is the THB-USB4-C2 connector. This is the THB-C1 connector. This is the connector for the noise detection sensor. There are 2 SATA data ports here, and there's also 2 SATA data ports here. This is the reset button. This is the CL2032 CMOS battery. This is the front panel connector. This is System Fan 1, System Fan 2, System Fan 3, System Fan 4 power connectors. This is the Q-Flash button. This is the front panel USB 1, front panel USB 2. This is SPI-TPM connector. This is LED-C connector. This is ARGB-V2 Set 1 connector. This is ARGB-V2 Set 3 connector. This is LED-demo connector. This is front audio connector. And by the way, this quick release and lock systems for the M.2 devices, these two locks are called the M.2 EZ-latch click. And these 1, 2, 3, 4, and 5 locks are called M.2 EZ-latch plus. On the back panel, the sockets available are 2 by USB 2.0/1.1 ports, 2 SMA antenna connectors, 2 by transmit, 2 by receive. These are 4 by USB 3.2 generation 1 ports. This is a display port input. This is a HDMI port. This is a USB 3.2 generation 2 type A port. This is a USB Type-C port display port with USB 3.2 generation 2 support. This is a USB Type-C port with USB 3.2 generation 2x2 support. This is also a USB 3.2 generation 2 Type A port. This is a 5 gigabit per second RJ45 Ethernet port. This is an optical SPDIF output port. This is a microphone input socket. This is a audio line out socket. To this side, these are the two ATX 12 volt 2x4 sockets. Rotate the view again. This is the ATX sockets, and those are the 4 SATA sockets. And the last view on this side, that's the front panel header socket connector. This is the front panel audio connector. These are system fans 1, 2, 3, and 4 power connectors. Now for a look at the underside of the motherboard. There is the ultra durable PCIe armor bracing bracket. This is to strengthen the PCIe X16 slot so that it can handle a heavy graphics card. And you can also see that this PCIe X16 slot has the ultra durable PCIe X armor to strengthen the size. I'll rotate the view from the top. Well, that's all from me for unboxing of the motherboard. Let's now unbox this Intel i9 CPU. This is the label on the box. It says it's the i9-14900K CPU, which suits the LGA1700 socket. There's a serial number. I've blocked that out. The box comes pre-sealed with a tape. I've already sliced through the tape. So if I open the box, there's a silver looking plastic disc, and it opens up, and the disc is simply sitting between two plastic brackets. There's a sleeve containing a instruction manual. There's a graphic depiction of the steps to install the CPU. The shiny looking plastic container. The container is split into two halves. There is a triangle notch on the top and a triangle notch on the bottom. They are not aligned, and when they're not aligned means the container is locked. To open it, I turn the two notches so they point towards each other, like that, and I can simply lift it open. And that's the Intel i9-14900K CPU. If I remove this and turn it over, you'll see the underside has all the pins. And if I remove this, might be able to see this better. You'll notice that there are 4 cut notches. 1, 2, 3, and 4. And the notches are spaced not equidistant. So the notch is closer to the right hand side and further from the left hand side. There is only one way to install this into the LGA1700 socket, by using the alignment notches. It is now time to install this CPU into this socket. Gently press the CPU socket lever handle down away from the socket. Completely lift up the CPU socket locking lever. Use the finger tap on the side of the metal load plate to lift open the metal load plate with the plastic protective cover attached to it. That's the plastic protective cover. Hold the CPU by the edges. Align the CPU triangle pin 1, which is here, top right corner, with the pin 1 corner of the CPU socket. And also align the 4 notches on the CPU with the 4 notches on the socket. And gently insert the CPU into position. So the 4 notches are now aligned and the triangle on the corner is aligned. It feels flush and not rocking. Make sure the CPU is properly installed and then close the load plate. And the cover will pop off like such. Now return the CPU socket lever handle down into its lock position. There. Everything looks good now. Looks secure. That's good. CPU installed. Let's unbox this G.Skill Trident Z5 64GB RAM. The product code for this RAM is F5-6400J3239G32GX2-TZ5RK. I use G.Skill's website RAM configurator to match the appropriate RAM to the Gigabyte motherboard model that I have. It gave several possibilities and I selected this model. It is a DDR5 RAM 6400 speed. Each of the 2 modules is 32GB and the timing is CL32-39-39-102 1.40 volts. There are 2 RAM modules inside. You'll be able to see the product number through these plastic windows. I've blocked out the serial numbers, but they are also depicted on the label. The package comes with a tape to seal it. I have previously opened the box. A plastic container containing the 2 RAM modules, 32GB RAM each. On the other side, there's a label with the RAM model number and also the serial number which I've taped out. These RAM have RGB lights on them. I did not want to have RGB lights, but it was very difficult to source for RAM without RGB, as I originally wanted RAM with the shorter height. Let's now install my 64GB of RAM into the RAM slots. I have 2 pieces of RAM module. One RAM module will be going into DDR5-A2, which is the second slot from the furthest one. This is A1, A2, B1, B2. So they will go to A2 and B2. Now, looking at the RAM module, it looks identical, this facing and this facing, but they are not identical because the length of the contacts are not equal. At a glance, the left side looks longer than the right side. Flick the RAM module lock off so that I can slide it in, gently placing them in line with the slot grooves without pressing anything in, just letting it sit there. You can see that that slot is too far to the right, does not match the divider there. This means the side with the label is not supposed to slot in this way. If I turn the RAM module around, gently slide it into the slot, it is now clear that the slot is aligned to the divider. So let it drop in there and it fits in there. Gently push it down. Flick the lock lever to lock it in and they're both secured. Now that I know which side is the correct facing to insert, I will insert the second RAM module into B2 slot. Release the lock tabs. Gently slide the RAM module in and it looks like it is aligned and is correct. Push the RAM module down gently and push the lock tabs back. Both RAM modules are now secure. This is the Western Digital Black SN850X NVMe SSD drive. This is a 2TB Gen 4 PCIe 4.0 SSD drive. Let's open it up. The drive is sandwiched in a plastic container. It has a serial number and I've just taped out the serial number. The reverse side is all black. There is a document. So I have two identical drives that are set up in RAID 1 mirroring configuration. I will now install the two SSD drives to the motherboard. Remove the heat sinks that cover the M.2 connectors. First, I'll remove the heat sink to the M2C-CPU connector. I push the easy latch click lock clockwise to remove this heat sink. Similarly, push the lock clockwise to this easy latch click to remove this large heatsink plate. This M2C-CPU connector is the only one that caters to PCIe 5.0. Hence, it has widest allowance for the 25110 or 2580 PCIe SSD drive. All the other connectors only support 22mm wide SSD drives, and so their separation is narrower as they support type 22110 or 2280 SSD drives. Initially, I thought because the manual specified this M.2 connector supports PCIe 5 of type 2510 or 2580 SSD drives, it did not say that it could support the narrower 22110 or 2280. However, because the PCIe 5.0 standard is backward compatible to PCIe 4.0, I should be able to fit a PCIe 4.0 SSD drive into this connector and fit a second one into this connector. The reason is these two M.2 connectors connect directly to the CPU, whereas all the other M.2 connectors connect via the south bridge. And because these two SSD drives mirror each other in RAID 1 configuration, I'd rather they have the same data path for reasons of speed. So first thing is I'll peel off this protective film on the bottom heatsink. Oops, I made a mistake. I actually peeled off the actual heat transfer layer, not just the protective film, so I'll put this back slowly. I've repasted the bottom thermal layer. Let me rub it down to make sure that it's secure. Now I have to carefully make sure I only peel the very thin plastic layer. Here we are. It's only the thin protective film I'm peeling off. Now I take my first SSD drive, insert it into the electrical contacts socket, push it in slightly. The sound clicks when it's secure. Turn the Easy Latch Plus counterclockwise. Push it back and that is now secure. Take the heatsink for the M2C-CPU. Peel off the protective film. Slowly align the tongue into the slot. When the tongue is inserted correctly into the slot at the front, push down gently, turn the Easy Latch click clockwise, and then push down gently and see that the Easy Latch click is fully secured in lock position. With the first SSD drive installed into the M2C-CPU connector, I will now install the second SSD drive into the M2A-CPU connector. Slot it into the electrical contact socket. There will be a click when it's secure. Turn the Easy Latch Plus lock clockwise. Push down on the SSD and then return the lock and ensure that it is now secure. I do not have any other SSD drives to connect, so I'll reinstall the top heatsink plate. Align the two slots to the two screws. Turn the Easy Latch click clockwise. Push down slightly. Ensure that the lock is now secure. So now I have my two SSD drives installed. Let's unbox the MSI MPG Gunyah 300p Airflow gaming case. I've previously cut open the top There is a packing foam on the top. There is a plastic wrapping. Pull that out and the top of the computer case is revealed. Looking at the top of the computer case, this is a removable grill. It is secured to the case by magnetic strips on the edge. So that is great, that's very convenient. No screws. At the front of the top of the case, there's a power button. There's a reset button. There is a earphone socket. There is a microphone socket. There is a USB 3.2 Generation 2 10 gigabits per second Type-C port. And there are two USB 3.2 Generation 1 5 gigabits a second Type-A port. The case is 235mm wide from left edge to right edge. The case is 510mm tall from the top to the bottom of the feet. The case is 505mm deep from the edge of the front panel right through to the screw at the rear end. The entire front panel of the case is perforated, and I like that because I want more air to be able to pass through the front of the case. The left hand side panel is see-through. I think it's made of glass. The right hand side is a metal panel with perforation holes on the bottom for airflow. This is what the rear of the case looks like. This is for the ATX power supply unit. This rectangular hole is where the back panel of the ATX motherboard extends outwards. There's a product serial number label on the back which I have blocked out. To remove the left hand side and right hand side panels, there are two null screws. This is a computer case which essentially I can assemble and disassemble without using tools, and that is fantastic. So to remove the left hand side panel, I undo this null screw and then pull the side panel out. Note that this metal bracket is secured to the side panel. You can see now the separation. Lift the panel out and that's it. So this is the side panel. From the sound, I'd say it's made of glass. Now to remove the right hand side panel, undo the null screw, push outwards and pull out. You can see that the side panels have three knobs on the top and three U-shaped catches on the bottom, as well as a knob on the rear, nothing on the front. And this is how it fixes to the chassis. On the bottom of the right hand side panel, there's a grill temporarily held in place during transport with paper masking tape. Remove them. I certainly do not want paper in the computer case when it is operating. Now I can just flick and release, and again this grill has magnetic strips on the side to secure it to the metal panel. I'll now remove the front panel grill. There's a slot in here. Simply put my 3 fingers into the slot and pull out gently. There. The front panel is secured to the metal frame with this 1, 2, 3, 4, 5, 6, 7, 8 plastic tubes. Because they are split, they slip in easily and then spring outwards to secure the cover. This is what the computer case looks like now with the front and both side panels removed. There are 3 120mm fans. These 3 fans at the front are intake fans. This is the right hand side. This is the cabling from the top front panel buttons and sockets, and this is power cabling to the 3 fans in the front panel. And here are all the termination connectors from all those cables. Again, this is the rear panel. If I unlock these 2 screws and just push out, there are 2 extraction fans, and this is what the removable rear panel looks like. This is just power cable to the fans. At the rear, there is a 120mm extraction fan. This computer case can accommodate both the ATX motherboard, which will sit in here. Those are the fixing screws for the motherboard. It will also accommodate the extended ATX motherboard. I'll remove this protective foam which has been inserted for transportation. This cable cover is presently installed in the position to accommodate the ATX motherboard. If an extended ATX motherboard is installed instead, then this cable cover needs to be shifted and fixed to this other screw position on the right to give more space for the extended ATX motherboard. This computer case can accommodate a graphics card to be installed either in a horizontal position or a vertical position. And the case has come pre-installed with a PCIe riser cable to cater to a vertically installed graphics card. This can be easily removed if the graphics card is inserted in a horizontal position directly into the motherboard. This is the graphics card holder. It is used to support various sizes of graphics card in either the horizontal position or a vertical position. I have turned the computer case to the underside. There is a grill. This grill can be removed by lifting the rear handle and pulling it towards the rear, and you will slide out. I will cut this cable tie off, and there is a fan on the hinge. I'm not sure which component this fan is intended to cool. There is a tie down cable. I will remove that cable so we can see the fan will swing out this way. This little fan must suck air in from this direction and out this direction. I'll now explain how this graphics card holder and this graphics card PCIe riser cable works. The motherboard will be fixed to these screws on the base. That means that a graphics card, when installed on the motherboard, will likely sit around this position. This is the graphics card I'll be using. It's a very short one and it's only PCIe 3, but I will test it out on my new system. I have here a much older graphics card, but it is much longer, and just for illustration purposes, I'll use this graphics card. If I mount it in this horizontal position on the motherboard, I can use this graphics card holder to support the graphics card, especially if it's one of the new large heavy graphics cards. To do that, I will have to adjust this graphics card holder position. I'll remove this. Notice there's a magnetic plastic cover. There is a screw I can turn by hand. I will loosen it. There's 5 horizontal positions I can shift this graphics card holder to. That's a reasonable range. In the case of this demonstration graphics card I have, if I install it on the motherboard in the horizontal position, I'll shift the graphics card holder to position 5 to see it will support that graphics card. Simply lift, and at the other end there's a catch. Slide it out, and you can see the slots 1, 2, 3, 4, 5 that this tab latches into. It's a metal tab, so that is good. And the other end is also a metal tab, so that is also good. This means it's not going to break easily. Slide position 5, lock in the length position with the screw. And now graphics card horizontally mounted to a motherboard would be there, and pull the tab up to support, and adjust the tab to correct positions for support. It's now supporting the graphics card. Pull out the protective film. If I now wish to mount the graphics card in this vertical position, I will turn this holder 90 degrees this way, release the arms. I'll pull the holder backwards, insert the graphics card in. Graphics card will sit in that position. I can adjust the bottom holder upwards to support the base of the graphics card. Push the holder inwards and you can see it supporting it. For the top support arm, I'll slide it down. Turn the arm outwards to lock the arm position. And that's it. In terms of radiator cooler compatibility, the rear can take a 120 or 140 millimeter radiator. The top can take a 280 or 360 millimeter radiator, and the front can take a 280 or 360 millimeter radiator. For my purpose, I will be installing a 360mm radiator at the top as an extraction fan. The box of accessories supplied with the 300p case comprises 10 cable ties for cable management, 1 L-shaped screwdriver for securing the vertical graphics card and bracket, packet of 35 screws of size M3 by 5mm for the motherboard, SSD and PCIe riser cable, packet of 4 screws of size 6-32 6mm for securing the power supply unit, packet of 4 screws of size number 6-32 6mm for securing the hard disk drive, packet of 8 screws of size number 6-32 7.5mm for securing the liquid cooling radiator, packet of 12 screws of size number 6-32 30mm for securing the liquid cooling radiator fan, a standoff mounting tool for securing motherboard and PCI riser cable, horizontal graphics card bracket for securing the horizontal graphics card, 1 packet of 2 screws of size 5mm 8mm long for securing the 80mm and 120mm fan. By way of comparison, this is the vertical graphics card bracket and is pre-installed in the case. For hard disk drive and SSD drive storage, there are 2 trays here. They are for 3.5-inch hard disk drives. If I squeeze on the prongs here and just pull it out, it extends out completely and can be withdrawn completely. So there are 2 of them. Each of these 2 trays will fit a standard 3.5-inch hard disk drive. These 2 trays are made of plastic. In addition, there are 4 pre-drilled holes where a 2.5-inch hard disk drive or SSD drive can be fixed to the tray. So reinsert and they are in. In addition to these 2 trays, there are 1, 2, 3 and 4 detachable trays to accommodate installation of 2.5-inch SSD drives. To remove a tray, simply unscrew this. It flicks open and then it simply unlatches. This is what it looks like. So there are 4 pre-drilled holes and a 2.5-inch SSD drive is installed by screwing it to the outside of this tray. In addition, inside the case, 2 more 2.5-inch SSD drives can be installed on top of the steel mesh above the power supply compartment. These are SSD tray 5 and tray 6. So in my view, this is adequate capacity for hard disk drive and SSD drive installation. Let's now unbox this Entech NE1000G M ATX 3.0 power supply. The Entech power supply is rated 80 plus gold, compliant to ATX 3.0 standard, and is equipped with PCIe 5.0 power cable. There is a Entech quality warranty card. There is a product overview document. There is an AC power cord supply. There is a bag containing the cables. There is a foam packaging containing a pouch that has the power supply unit. So here is the power supply unit. There's a product serial number label I've blocked out. The rear of the power supply unit where all the cables connect to. This is a socket for 12 volt HPWR. These are sockets for PCIe/CPU. These are the sockets for SATA/Molex. This is the socket for 18-pin motherboard power. Socket for 10-pin motherboard power. The front of the power supply unit. A button for hybrid mode, on-off switch, socket for the AC power input. The top of the device has a cooling fan. So here is the pouch with all the cables. Well, that's it. This is what comes supplied with this power supply unit. I will now install the motherboard to the case. I will remove the cable tie that restrains this graphics card cable. Here we are, that's removed. So I can slot the motherboard in there. To give myself enough room to maneuver as I install the motherboard to the base here, I've moved the graphics card holder to the front. And I will also remove this vertical graphics card data cable. Here it is. I'll fix the screws back in this socket position so I do not lose these screws. That's good. I have a lot more space to work with now. Let's unbox this Thermaltake Tough Liquid 360 ARGB Sync all-in-one liquid cooler. Open at the end of the box. It is sealed with the tape. I've cut the tape. And the lid opens. Packing foam. There's a SATA power cable. This is the radiator and this is the water pump. These are the various mounting brackets and screws. There are 3 identical 120mm fans. The model is TT1225. There's one sheet of 2-page installation guide. The guide covers installation for a Intel CPU and also an AMD CPU. There is a warranty policy document. Print is so small, I think only 10-year-old kids can read it. So we have the radiator and the water pump, the 3 fans. There are 2 cables. One is a SATA power cable and the other one is a 3-pin cable. And here is the packet of mounting frames, screws, and also CPU thermal paste. A close-up view of the radiator. There are 2 sockets. I believe this socket on the right hand side is for a cable to synchronize to the motherboard ARGB controller. And I believe this socket on the left hand side when using the ARGB controller on the water pump. On the water pump there are 3 switches. It's click to activate, 1 switch for mode, 1 switch for color, 1 switch for speed. There are 7 LED modes to switch from. There's rainbow, full light, RGB spectrum, off, flow, radar, pulse, and blink. For color mode, when the light mode is in full lighted, pulse, or blink, it is possible to switch over 8 LED colors: red, yellow, green, teal, blue, white, purple, and rainbow. When the light is in ripple mode, it's possible to switch over the 7 colors: red, yellow, green, teal, blue, white, and purple. When the light mode is in RGB spectrum, click to memorize and lock the color you want. Click again to unlock the 256 colors auto rotation. When the light mode is in wave and flow, LED color cannot be adjusted. The light speed switch enables switching over between 4 light modes: slow, normal, fast, and extreme. This is the heatsink cold plate, and there's a protective film that must be removed before installing this cold plate to the CPU. The hoses look fairly robust. This cable connected to the water pump is a 3-pin plug for power to connect to the motherboard. The 2 cables in this packet, one cable is a SATA power cable and the other cable is a 3-pin cable. If I want to use the ARGB control buttons built into the water pump body, then I would use this SATA cable and plug this white plug end into the white socket. But because I will be controlling the ARGB lights from the motherboard, so instead I will use this second cable And this is a 4-pin plug that will fit into this 4-pin socket. In preparation to install the Thermaltake Tough Liquid 360 radiator fans to my computer case and also the water pump to the top of the CPU, I've set up all the components that are supplied with that radiator fan product. I label all the screws like this because the plastic packs that the screws came in had no labels to say whether they were G screws, H screws, K, J, I or F. So I did this to make it clearer for myself. I also labeled the back plates and the front plates. The back plates are used for the Intel sockets. This one is for the Intel LGA 1700 socket. You might be able to see that there's a little engraving that says LGA 1700. So the way I'm holding it is the way it needs to mount to the underside of the motherboard directly below the CPU socket. These are adhesive tapes that need to be uncovered before installation to the bottom of the CPU socket. This is the D back plate for use with the Intel LGA 1200/115X socket set. This is the E front plate for AMD install. And for this front plate, there is no label in the user manual. This is the thermal paste. And this is a 3-in-1 power cable for the radiator fans. I have here a bottle of isopropyl alcohol and some cotton wool. I'll spray some alcohol to the cotton wool. Gently wipe the metal surface to remove dirt and oil film. Let it dry for a while. Remove the protective film from the adhesive strips. Now I orientate these two strips parallel to the long side of the rectangle. Turn the adhesive towards the metal and align the 4 screw holes to the 4 holes on the motherboard. Gently press the 2 adhesive tapes onto the metal frame. Turn the motherboard over back to the top facing. Get one of the 4 H screws with the shorter screw thread facing downwards into the motherboard. Screw it into one of the 4 screw holes. Get the second H screw with the short end again pointing downwards into the motherboard. Screw it diagonally into the second screw hole and hand tighten. It may be a bit difficult because there's not enough area to turn the knurled surface. The third H screw into the third hole and the 4th H screw into the 4th and last hole. Make sure not to over tighten, and that is good. Turn over, check, and that feels secure. That is good so far. Now to install the motherboard into the case. There are 9 screw holes, 1, 2, 3 on the right, 1, 2, 3 in the middle, and 1, 2, 3 on the left. These are the screws I will need to fix the motherboard to the case. Put the screw in the top right corner. Second screw in the bottom left corner. Third screw in the bottom right corner. 4th screw in the top left corner. 5th screw in the middle center. 6th screw in the middle right. 7th screw in the middle left. 8th screw in the center top. 9th screw in the center bottom. All 9 screws are now fixed, so that's good. I'll now reinstall the vertical graphics card cable connector. Remove the plastic protective sleeve on the PCIe X16 interface. Match the slot on the connector to the divider in the socket. Gently push it in on both sides equally. When it's correctly installed, this lock lever will rise to lock the connector in place. With the connector in place, I'll now find which hole positions to use to minimize twisting the cables. The best hole positions to use are that one and that one. First screw in. Make sure there are no cables that are in the way. Second screw in now. Tighten it. That's good. I will need to slide this front plate into the slot around the base of this water pump. And the 3 switches in this facing, the opening needs to go in here. Push all the way in until it clicks. So this is what it looks like when the front plate is installed to the base of the water pump. Next, I'll install the 3 fans to the radiator. This face is facing into the case. When I mount the fans in this direction, it will be sucking air from inside the case out through the radiator to the external environment. How do I know which side of the fan is intake and which side is exhaust? The key is that on the side of the fan, there is a symbol. In this case, there is an arrow pointing that direction. That means air is sucked in through here, this side, and exhaust through that side. And it also shows an arrow to show the direction of spin of the fan. So I know this is intake, that is exhaust. I will be mounting the fan this way. But before I install the fan, I want to remove the thin protective plastic film. There's a film on both sides, so I must make sure I remove it, otherwise this will overheat and become a fire hazard. To fix the fans to the radiators, I will need this J screws and a Phillips head number 2 screwdriver. With all the 3 fans in place, I can now tighten the screws. All 3 fans are securely installed, so before I install the water pump to the CPU, I prefer to install the radiator to the top of the case first. I'll be installing the radiator by fixing the screws into these slots. For this, I'll be using the K screws. First screw in here. I'm setting the radiator further back so that there's space for the water hoses in front. That's good, all 12 screws are secured. So the radiator with the fans is installed to the top case now, and the intake and outflow hoses are on the side. They're not touching the front casing fans, so that's good. So what will happen is I'll likely be fixing the water pump in this orientation. I may also consider installing the water pump in this orientation to the side. I'll have a think about it. Power for the water pump will be supplied through this 3-pin plug. I'll connect the power cable to this System Fan 6-pump header on the motherboard. It has 4 pins, but if you look at the underside of the plug, there are 2 ridges, and these ridges slide into this tongue when only 3 of the 4 pins are used. To control the ARGB, there are 2 ways to do this. The first way is to use the onboard switch controllers on the water pump itself, and to do that, I'll have to use this cable with the SATA plug that will connect to a SATA power supply cable from the power supply unit. The second method to control the ARGB lights is to use the ARGB controller on the motherboard. In this case, I will use this second cable. There's a 4-pin plug that fits into this, and at the other end it will go into the motherboard. To install the water pump, I'll remove the protective film on the cold plate. This is the thermal paste provided with the Thermaltake Tough Liquid radiator cooler. I will not be using it. Instead, I'll be using this Cooler Master thermal paste that I purchased. So this is the Cooler Master High Performance Thermal Paste. I'll be applying a complete smear over the entire CPU. I cut little cardboard strip as an applicator. I think that's adequately and evenly spread. With the protective film on the water pump cold plate removed, I will now align the 4 slots to the 4 screws like this. And now I'll use the 4 eye screws to fix the water pump into position. 2 screws are in. Now fix the 3rd screw. And now the 4th screw. I will now tighten all these 4 screws. They need to be tight in order to ensure that the cold plate on the water pump is flushed and tight against the CPU. I've checked all 4 screws are completely tightened. That's good. Just give it a wobble test. No, it's not wobbling. I'll remove this plastic protective film. So far, so good. I'll now connect this power supply cable from the water pump into the system fan 6-pump header. As I mentioned, this is a 3-pin plug. That's a 4-pin header, but there's a tongue here to guide the 3-pin plug so that it slots only into the bottom 3 pins like this. So that's good. I've just stuck a piece of paper over the mirror surface on the water pump so that I don't get unnecessary reflection and glare. My next step is to connect power to the 3 radiator fans. Untie the cables, straighten all the cables to make sure there's no twist. The 3 plug ends, and this is the supplied 3-in-1 power cable adapter. Fit the 3 plugs into the 3 sockets. There's only one way to do it because it's guided by the groove and the tongue. So all 3 plugs are connected, and this is the 4-pin plug end that I will connect into the CPU fan 4-pin header. Let the slot be aligned with the tongue. That's it. To control the water pump's ARGB, I've opted to use the cable with the ARGB plug, which means that I connect to the socket on the bottom. This will allow me to use my motherboard's onboard ARGB control. The motherboard has 3 ARGB headers, one here, and one on the top right of the motherboard. I've temporarily removed the graphics PCI EX16 cable so that I can gain access to these 2 ARGB headers. So I'll connect the ARGB cable from the water pump to this header here on the left. I just have to be careful that there are 3 pins and a blocked out pin. Make sure I have it in the right orientation, otherwise I'll be breaking a pin on the header. So that is now connected. There is also a ARGB plug on this graphics card support holder. I'll plug that into this second ARGB header. That's good. I now have 4 sets of fans to connect power to the system fan headers on the motherboard. This first plug is for these 2 small fans at the rear. Check my orientation. The slots are guided by the tongue. I'll put it into this leftmost header. Done. This next power connector is for this 120mm extraction fan in the rear. Check the slot against the tongue. Align the slot on the base of connector to the tongue at the header and slot it in. That's done. This third power plug is for this small fan at the front. Check the slot orientation. Align it to the tongue on the header and slot it in. That's done. And the last power connector is for the 3 fans in the front panel. Slot it in. Now all 4 sets of fans will be powered by the motherboard. So that's good. I've also used cable ties to tidy up the cables from the various fans. Here, there. What I'll do now is attach the various cables from the front panel onto the motherboard. This is the JUSB connector. It has 2 cables leading to the 2 USB 3.2 generation 1 sockets at the top front of the panel here. There's a bit of a protrusion at the center. It's a guide, and that needs to fit into this F-U32 slot on the motherboard. So that's done. Next, I have the JUSB connector for the USB 3.2 generation 2 socket at the top front of the panel here. That connector needs to slot into this connector on the motherboard called the F-U320G, which supports USB 3.2 generation 2x2. Again, there's an orientation to it. I just have to ensure that I orient it in the correct direction. There is a click when it's properly engaged in the connector. The next connector to install is the front panel audio connector for microphone and earphone jacks. Needs to be installed into this F audio socket on the motherboard. I need to be careful because one of the pinholes is blocked, so I need to orient this plug into the socket correctly and not break a pin. It appears that the bottom row, second pin to the left, is not there, and so that's where that blocked pin on the plug itself needs to fit to. The audio connector is now correctly installed. The next connector to install on the motherboard is the front panel connector, which joins to the power switch and the reset button on the front panel. There is a blocked pinhole on the bottom right hand side. This means that in order to fit the front panel header here, I have to orient the connector so that the word F panel is on top and slot it to the extreme left hand side of the header. That's done. My next step is to install the power cables to the Entech NE1000G M power supply unit. I've laid out the cables supplied. There's a 24-pin ATX cable. There are 2 sets of 4+4 ATX cables. There are 4 sets of PCIe 4.0 6+2 pin cables. There are 3 sets of SATA power cables. There is one 4x1 hard disk drive cable. There is one PCIe 5.0 12+4 pin power cable. I will not need to install all these cables, so I'll only select those that I need. So this is the 10 pin, this is the 18 pin ATX power supply. This will fit into that socket and that will fit into this socket. That's done. Next 2 cables to fit are these 8 pin ATX CPU cables. I'll connect them to these 2 sockets. Just note that the connector ends are different. One connector has the small catch, the other one has the large catch. So this connector small catch fits to the power supply unit and the other end fits onto the motherboard. Same thing for the second cable. I will also fit one of the PCIe cables, and similarly the catch is different. There's the small width catch and the thicker width catch. The connector with the smaller width catch fits into the power supply unit. This is one of the SATA power cables. I will connect one of these. They will go to the lower slots marked SATA or Molex. I do not need to connect anything else, and if I do in future, then I'll just remove the power supply unit and install additional cables. Put the 4 screws to fix the power supply unit to the case. That's done. That's now installed. I have routed these 2 8-pin CPU power connectors through this bottom hole, and I've routed this 24-pin ATX connector through that hole. I'll now connect this plug to that socket. There's a catch on the plug. That catch is to be on the right hand side of this socket. That's good, that is securely engaged. Next, these 2 connectors, same thing, plug has a catch. That catch is on the top side. First connector is in. Those 2 connectors are now engaged. So far so good. I'll reinstall the existing Gigabyte GV-N1656OC-4GD graphics card. However, I could not connect power from my Entech 1000 watt power supply unit to this old graphics card because this graphics card has a 6-pin PCIe power socket, whereas on my power supply, the PCIe power outlets are all 8-pin. So I tried using an old 8-pin to 6-pin PCIe power cable, but it still did not work. When I start up the computer with this graphics card, the monitor said I need to attach PCIe power cords to all the graphics card. In any case, I decided that since I was building a powerful computer using Intel i9-14900K CPU with 64 gigabytes of RAM, I might as well upgrade my graphics card. So I bought this MSI GeForce RTX 4060 Ti Ventus 3X 16GB OC graphics card. Because this card is PCIe 4 generation, it has an 8-pin power socket, so it will work with the power cable supplied by my Entech power supply. So that's good. Let us unbox this MSI GeForce RTX 4060 Ti Ventus 3X graphics card. Nice looking box. And on the side, there's a serial number which I've blanked out. To open, at the end, there's a tab. Open the tab. I can slide the package out. Just a foam top cover, a spacer foam, and the graphics card. The back was sealed, but I've just untaped the seal. There is also a quick start guide. And this is what the graphics card looks like. 3 fans, 8-pin power socket, and the PCIe interface is protected with a plastic shield. This has 16GB RAM. There is a 2-fan version of it. On the rear panel, there's 1 HDMI port and 1, 2, 3 DisplayPort sockets. This should serve me well. On the motherboard, this is the PCIe X16 graphics card slot. So I will have to first remove this rear panel. Now with the graphics card in hand, remove the protective rubber sleeve. Slide the graphics card in. Turn the connection interface towards the PCIe X16 slot, and I have adjusted the height and position of this graphics card holder so that it will support the end of the graphics card, as this is a very long card. It's in position now to slot it in. Make sure that the PCIe X16 slot lock is engaged. I may shift this down a little. Now that the card is slotted in, I will reinstall the back panel. That's good. It's clipped in nicely with the video output ports exposed. That's good. Now I have to use these screws to secure the graphics card to the rear panel. Second screw. That's good. Both screws are in. What I would like to do now is shift this graphics card holder more to the left so that it grabs more of the graphics card body. To move this holder across, I remove the magnetic cover. Use the thumb screw to release. Then pull it out slightly. Lift it on the next position towards the back. Slide it in to the slot at the front. That's locked in. Now return the screw. Put the magnetic cover back on, and then adjust the height of this lower support arm so that it's actually supporting the base of the graphics card, like such. And then for the top, I shall adjust it as well so that it's sandwiching the top. There, the lower arm and the upper arm are grabbing the graphics card, and you can see that it is fairly rigid. That's good. Next, this is the 8-pin PCIe power plug coming from the power supply unit. I will plug that in, being careful that the catch tab is on top to match the socket. That's good. I have here my assembled computer, including the new graphics card. So the graphics card is connected by HDMI cable to this monitor. Power supply turn on. Turn the computer power switch on. All 3 front fans are working. Radiator fans on the top are working. Rear fan is working. The little fan inside is working. 1, 2, 3, 4 RGB lights are working, so that's good. The graphics card is correctly signaling to the monitor. So this is the BIOS application from the motherboard. That's good. Success. It is time for me to install a few of the small items that I've left out. This is a noise detection microphone. These are 2 temperature sensing thermistors. And lastly, the antenna. I will not be using Wi-Fi. However, I feel that it's important to still connect the antenna, because if I accidentally activate the Wi-Fi without an antenna connected, it can damage the Wi-Fi system. So first off, let me install the noise detection microphone. On the motherboard, the socket for the noise sensor detector is there. And physically, that is the location. I should have installed the microphone and the temperature sensors before I installed the graphics card, but I'll try and work around it. On that noise detection socket, there's actually a plug inserted into that socket. So I pull this plug out first. I will now take out the noise detection microphone. That's the connector end. There's only one way that it will fit, so be careful not to push it in the wrong way. The contact holes are closer to one side. If I look at the socket, I can tell which side the prongs are that are closer to the edge. So that's the direction I need to insert it in. So that's the socket. Okay, it's in. There are two sets of adhesive tape that will allow me to tape the cable to the case. So the microphone is located here. Next is to install the two temperature sensors. The first temperature sensor is to be connected to the 2 pins EC-Temp1. Temperature sensor is installed. I will deploy this first temperature sensor at the base of the computer case. I'll cable tie it later. The second set of pins for the temperature sensor are located here. This is called EC-Temp2. That's joined. For this second temperature sensor, I will install it so that it's hanging from the top. So the two thermal sensors are installed. The connector is installed there to EC-Temp1. And the temperature sensor probe is located here at the base of the case. The second temperature sensor, the contact is connected there on the motherboard. And the temperature sensor probe, I have installed it at the top of the case. So this will give me a temperature differential from the base of the case to the top of the case. The last accessory to install is the antenna. These are two SMA connectors I mentioned previously. I do not intend to use Wi-Fi to connect the computer to my network router. I will definitely connect the computer to the router using RJ45 Ethernet cable. And I'll use the Windows 11 operating system to deactivate Wi-Fi. Nevertheless, if I actually turn the Wi-Fi system on and the system attempts to broadcast a signal, it may damage the Wi-Fi system if there is no antenna connected. So for that reason, I will connect the antennas even when I do not intend to use them. Temporarily, for the moment, I will just leave the antenna on the top of the case. Well, that's it for me with the physical installation. The next step is to configure the BIOS so that it will accept my two Western Digital SSD drives and set up RAID 1 configurations. Having now installed all the hardware to build my Beast PC number 3 computer, I will now configure the BIOS settings so that I can set up RAID 1 configuration for this pair of SSD drives. At this point in time, I will not be making performance changes to the BIOS settings. Merely want to get the BIOS ready to accept the two SSD drives in a RAID 1 setup. What I will do, however, is I will change the time. I will be using this instruction from Gigabyte to set up RAID 1 for the Z790 motherboard. Go to Settings, select I/O ports, select SATA configuration. I don't actually understand why, given the fact I'm not using SATA but NVMe, but I'll follow through and see what happens. Instruction says to make sure SATA controller is enabled, and that's this. Yes, it is enabled. Then it says to create RAID configuration, go to Settings, I/O ports, VMD setup. So I'll click on Settings again, go to I/O ports, go to VMD setup menu, enable VMD controller, set it to enable. So it is now set to enable, and where it says enable VMD global mapping, it's presently set on enable. I have to change it to disable. So this has been changed to disable. Then it says depending on the SATA/M.2 connector you use, set the corresponding map this root port under VMD item to enable. So here we are, double click on this. This is map this root port under VMD. It is set to enable. I'm now supposed to reboot the system, so I will save, select save and exit setup. Save configuration and reset yes. So it actually tells me what I did, the changes that I made, and if I agree with it, then to yes, save the configuration and reset. Okay, it's rebooted. So the next step, go to Settings, I/O ports, select Intel Rapid Storage Technology. Intel Rapid Storage Technology. So under this menu, it says there are two non-RAID physical disks. They are the two Western Digital SSD drives I've installed, so that's correct. What I'll do next is select Create RAID Volume. I can give the RAID volume a name. I'll select and give it a name. I will call this RAID volume Beast PC3 Volume 1. Click OK to select. For RAID level, it shows the default is RAID 0, which is stripe. I'll click on this and I'll change it to RAID 1 mirror because I want protection, not speed. Click to accept. It now shows RAID 1 mirror. Double click on the first disk, brings it up. I'll just click on this. That shows it's selected. You see an X in the bar here. Go to the second disk, double click on it, select X, double click, and now the two disks are selected to form the RAID 1 configuration. Now I'll go to create volume, and it says create a volume with the settings specified above. I'll double click. Brings up RAID volumes, Beast PC3 underscore volume 1, RAID 1, 1.8 terabyte normal. I'll double click on it. So the RAID volume has been created as a RAID 1 mirrored pair, and it says the status is normal and it is bootable. So that's good. Press escape to go back. So that was it. That's simple. I will see if there's some minor changes I'll make before I install Windows 11 Pro. I'll select USB configuration. It says legacy USB support is enabled. I can disable it or auto. In auto option, it disables legacy support if no USB devices are connected, whereas disable option will keep USB devices available only for EFI applications. I'll try auto. Everything else I'll keep. Escape to go back. Network stack configuration. I will keep it disabled because enabling it will enable booting from the network, and I do not need that. NVMe configuration. Interesting, it says no NVMe devices found. Maybe that is because it has been set up as a RAID configuration. SATA configuration. I do not have any SATA drives. I think that's it. I will save and exit. So I'll save this configuration and reset. Now that I've configured the BIOS to have RAID 1 for the two SSD drives, it is now time for me to install my Windows 11 Pro. So this is the install software for the Windows 11 Pro 64-bit USB drive. I'll stick it into the computer USB socket and then reboot the computer. It's reading from the USB drive. That's good. So it's booting up. Excellent. Language to install: UK English, time and currency format, English Australia, keyboard and input method, US keyboard. Enter language and preferred preferences. Click next or finish. Click next. Click on install now. It says to activate Windows, and the product key looks like that. So I have the product key in the card form with the package. I shall enter the product key now. I've entered the complete product key and I'll click next. It says applicable notices and license terms. Supposed to read all that. I'll accept the Microsoft license terms. What type of installation do I want? It's not an upgrade, so it'll be a customized install. It says where do you want to install Windows? Refresh to see if it sees the RAID drive. Couldn't find any drives. I wonder why. I'm guessing I need to load the Intel Rapid Storage Technology device drivers. I've put all the Gigabyte Z790 Aorus Pro X drivers into this USB drive. I'll insert this into the USB socket on the computer. See if I can install the RAID driver. So I'll click load driver, click browse. This is the USB drive with the drivers. I'll open that up. It will be under this Gigabyte Z790 Aorus Pro X mobile folder. Drivers. It will be under this SATA RAID AHCI folder. Under the folder pre-installed driver, I'll search under this folder and try. Excellent, it's found several controllers. The instruction manual says to use this top driver, Intel RST VMD controller 467F. So that's driver to use. I'll click next. It's installing that driver. So that's worked. It's identified the RAID drive. has 1.8 terabytes free space. I will select this drive to install Windows and click next. Success. Good, it's progressing, it's copying Windows files. Excellent. Gee, that is fast using SSD drives. It's now progressing, getting files ready for installation. It's rebooting, but with SSD drives, reboot is so fast. It asks, is this the right country or region? Australia is correct. I'll say yes. Is this the right keyboard layout? I'll say United Kingdom. Correct. Yes. It asks, do you want to add a second keyboard? I'll skip. It says, let's connect you to a network. I don't have a network connected. Seems to require it. I've now connected the computer by Ethernet to my router. I can press next. It's checking for updates. Looks like it's rebooting. I will call it Beast PC3. Press next. It asks, how would you like to set up this device? Set up for personal use or set it up for work or school? It is for personal use and I have full control over this device. I have a Microsoft account, so I will sign in to my Microsoft account. It sent a code to my email account to punch in. I've entered it. Seems to be successful. It says welcome back. That's excellent. I'll click on more options. I have a Dell laptop, a Beast PC2. I don't want restore from any other computer. I want to set this up as a new computer, so I'll choose setup as a new PC. It wants me to create a PIN from my Microsoft account, so I'll create a PIN. I've entered the PIN. I'll click OK to progress. Ask me to choose privacy settings. Want to provide me location-based information? I'll say no. Find my device? No, because this is desktop computer. Send info about websites I'm browsing? No. Inking, typing? No. Tailor experience? No. Advertising ID? No. I will accept the changes I made. Says, let's customize your experience. Development? No. Entertainment? Click yes. Gaming? Yes. Creativity? I'll say yes. Business? No. Connect family? No. I'll accept the changes I made. To use your phone from your PC, for Android phones, scan the QR code. So I will scan the QR code, open it on my phone, and I'll enter this code into the application on my phone, which has come out from scanning the QR code, so that my phone is now linked to this Windows OS. So my Microsoft account and phone are now linked. Click next. Always have access to your recent browsing data. I'll say not now. Get your first month of PC Games Pass. I'll say skip for now. It's now checking for updates. This might take a few minutes. Don't turn off your PC. Alright, it looks like it's finished installation. Excellent. So it's the bare desktop. That's success. I have the option to download and install Gigabyte Control Center. Would I like to install it? I'll say yes. So it's downloading the Gigabyte Control Center software. Welcome to Gigabyte Control Center 23.10.23.01 setup. I'll click next. Whatever is the license agreement, I'll say I agree. It's finished the setup. Click finish. Installation successful. That's it. Project success. I'm so pleased. This will be a much faster, better computer for me to use, especially for my video editing. Hi, I'm hiding behind the computer equipment. It has been a very successful installation project for me, and I have enjoyed doing it very much. I like this MSI MPG Gunyah 300p computer case. I think it's brilliant. It's got a lot of fans, and that is always good. And the fans are very silent. I've installed a MSI GeForce RTX 4060 Ti Ventus 3X graphics card, and I still have lots of space. I've installed the Gigabyte Z790 Aorus Pro X Revision 1.0 motherboard. I like the quality of the motherboard, and I've been able to connect all the cabling from the computer case to the motherboard connectors. I've installed quantity 2 of the Western Digital SN850X NVMe solid state drives. And with this motherboard, CPU and the solid state drives, installing Windows 11 Pro was so fast. To provide power to the computer, I've installed an Entech NE1000G M ATX 3.0 power supply unit. I will have more than ample clean power supply for my computer. To provide cooling for the Intel i9-14900K CPU, I have installed the Thermaltake Tough Liquid 360 ARGB Sync 3-fan radiator cooler. It's installed to the top of the case, and the fans are very quiet. I do hope you found the selection of the components I used for this computer and the build-up of the system interesting and useful. Do hit the like button and subscribe to my channel for more and help the channel grow. Thank you so much.